Welcome everyone to the first Algorand event of 2022. This is a great continuation of our Algorand programming from last year when we also had an Educate series and a hackathon. Guys that have been with us last year will remember Russ and Ryan, who did several fantastic workshops, and they'll be doing them again as part of the Educate series and the hackathon. So just a brief introduction. I'm Vanessa. I'm the operations lead at Encode Club. We are a Web3 education community. We do educational series, hackathons, coding bootcamps, and accelerators. And this year with Algorand, we're going to be doing a teal coding bootcamp, which is a new thing. Applications are open, and Eva will post an announcement link and a registration link in the chat below. You guys can apply. The bootcamp is due to start end of May. So if you want to participate, make sure to apply as soon as possible so we consider your application. Now, not to bore you anymore with the dull stuff, I'm going to hand over to Russ and Ryan for the stuff you actually came here to listen to. So thank you, guys.
Thanks, Vanessa. Appreciate it. Let's go ahead and get started here. I'll bring up the screen and everybody see this okay? Let's see. How's that look?
Looks good.
All right. So also have my coworker here, friend and confidant, Ryan here, Ryan Fox. Ryan, you want to go ahead and introduce yourself?
Thanks very much, Russ. I'm Ryan Fox. I'm a developer advocate here at Algorand, and I'm thrilled you guys are here participating in the Encode Club. So thanks very much. I'll be giving a presentation tomorrow, same time. So let's see what Russ has got on tap for us today.
Thanks, and I'll be doing the Q&A tomorrow. So we're going to flip roles tomorrow. Anyway, let's go ahead and get going. My name is Russ Fustino. I'm also a developer advocate on DevRel team. There's my LinkedIn in case you want to hook up over there. And we're going to do a blockchain for developers intro today, as well as I want to get this poll here. Ryan, if you can post that link in the chat window, that'd be great. Just go ahead and scan that QR code, and we'll get the lay of the land here in terms of the experience level of the group, so I can kind of guide today's presentation. So let me just bring that up and show you the live poll here, and you'll see that QR code over there as well. So go ahead and start answering this. So the first question, we got 3 of them total. Your experience level with Algorand blockchain, pick up to 2, more than 6 months. A good number of you brand new to Algorand blockchain. Then also we got less than 6 months with Algorand. So, and then, but good number of folks have some experience, and there's a bunch that are brand new to Algorand blockchain that are coming in. So that's a good showing here. And the votes are starting to come in now, a little bit more on the brand new. So that's good. We got you covered. And for those that have some experience, repetition is never a bad thing, at least for the first few minutes of this section. And we got some new use cases to share with you, and a lot of Algorand's been in the news a lot lately, so we'll kind of cover a few of those highlights as well. All right, so let's go to the second question here. About 61% there are new. So let's go to the second question. So what languages do you prefer to code? Check all that apply. If you're not a developer, just click on that one. And if you are, go ahead and select which ones you like. We got Python, Java, JavaScript, C#. We got Go as well listed in the list here. We got a lot of Python and JavaScript. Good number there for that. All right, this is very useful. Appreciate y'all. If you can please participate in this. This will give us a good accurate readout and know which demos to kind of highlight based on the language levels and all that kind of stuff. All right, this is all looking good. And we're going to do about an hour-long presentation here today, and lots of good resources we're going to point out for you, and a lot of good demos as well. Okay, so a good number there with JavaScript and Python. Next up is the final question in our poll. I really appreciate you all doing this. So experience building decentralized apps or dApps, check all that apply. Are you brand new? You have some experience maybe with Reach or PyTeal or Teal. And if you've built apps on Ethereum, that's another poll question here. And then also, some experience with the different, if you built dApps on other ones too. So we got a few that have built dApps on Ethereum, and then built dApps on other blockchains as well. Some experience with Reach, few of you. dApps on Algorand. Okay, very small percentage there. And PyTeal and Teal, rounding it out at the bottom. Okay, this is great. So we have a good mix of experience here. We got some folks that have been doing it for a while, and we've got a lot of new folks. We're going to kind of go right down the middle in terms of the level here. And let's go ahead and continue on with the presentation. Thank you so much for doing that. So what blockchain developers need to know is basically, hey, what is blockchain and why do I care? Especially for the new folks. I know this was always a big question. And this was even a bigger one for me when I first started doing blockchain development. What types of solutions can I build on blockchain? And given the fact that we're kicking off this this new session here, maybe this will give you some ideas when we start talking about this for different projects that you might want to do. And then what kind of programming languages can I use? Developers like to really pick the language they're strong with, right? And build on that. They really don't want to learn new languages typically. Sometimes you got to do that. But a big question here is how can I build a dApp? Very, very little experience that in the group. So we're going to cover that and get you going there. And how about the ecosystem? What tools are available that third parties are creating, and really developers at large in the Algorand developer ecosystem. Lots of good stuff here today. So the agenda, we're going to cover blockchain intro first. We'll do a quick intro there. Also start talking about layer 1 and what that is and what's available there, as well as getting started in the ecosystem. So basically, this is an immutable decentralized ledger is the way you can think of an Algorand blockchain. Anybody can get a copy of this. You just got to run a node, and then you have your own local instance of this ledger. But what's in the ledger? Well, it's a very simple 5 record types, basically. You got blocks, which is a slice of time. Our blocks are generated in under 5 seconds. So during that 5 seconds, what are the transactions that occur? So those are associated with that time period. And then transactions are between accounts, right? A sender and receiver. And then the accounts also have things like assets or ASAs associated with them, or fungible, non-fungible tokens, and the applications, which are your smart contracts and dApps. So let's talk about use cases here. The very first one, big one, is DeFi, right? This is just exploding. If you're looking at any vertical market in terms of the types of solutions that are being built today on blockchain, this is the winner by far. And why is that? Well, you've got a lot of reasons here. One, here you're seeing something about stable coins. We have one of the knocks on crypto is the fact that it fluctuates so much. So it's very difficult to do transactions with that. Whereas with stable coins, these are tied to like an economy, like the US economy. And so you can see here, we've got USDC, for example, is a really big one at over 3 billion in circulation, and other ones that are on the Algorand blockchain. And then you get into decentralized exchanges or DEXs and things like TinyMan, AlgoDex, AlgoFi. What's been happening is the fact that, for the longest time, we've been working with centralized banking. And so centralized banks have all the tools, all the finance tools. You needed to go to a bank to build a stock portfolio, all that kind of stuff. Well, now all these tools are available to everyone. And that is a real big game changer. And also the fact that there's no middleman, right? When you're doing exchanges and transactions, there's a sender and the receiver. This is very, very attractive for many folks. And the fact that you can do this globally, I mean, just think about how you'd send a transaction to, I don't know, I live down in Tampa, Florida, USA, and say I have a friend up in Canada, and I want to send him or her some money. How do you do that, right? You got to go through SWIFT, you got to through a bank, you got to go TransUnion, all this kind of stuff. And this takes a long time. And those aren't always available. There's over 2 billion people on this planet that lack access to modern financial services. But you know what? A lot of those have a phone, and a lot of those have internet. So this is a really good thing that blockchain is facilitating, and really just this one vertical alone. But wait, there's more, right? So we had a big announcement this week on FIFA, right? Announces a partnership with Algorand. This was huge. You know, if you look at the popularity of soccer worldwide and football worldwide, it is a mind-boggling. It's even a greater viewership than the Super Bowl. You know, when you get down to the championship. So this is really huge. And what kind of partnership this is? Well, it's not only marketing, but it's also technical, right? Algorand became the official blockchain platform for FIFA. And this was a really big announcement that we had this week. And, you know, a lot of folks worked hard on this and you know, this is just a start, right? They're going to be using blockchain for ticketing. That's another great application. Going to be using blockchain for, you know, maybe reselling tickets, right, and getting portions of that. You know, that market was unavailable before. And then also, not to mention NFTs, right, for all the players and teams. So very exciting times here with this announcement. It's huge. Also, recently, back in on Earth Day in April, a few weeks ago. We had there's a couple stories on this one slide here. All right, one is the fact that, you know, the blockchain Algorand is green and it's carbon negative, and so we actually have you know, smart contracts that are self-executing code that will contribute to green initiatives. And so what we did was we turned off all the lights, all the billboards in Times Square for an hour to represent you know, all the power that would normally be used during that period. And all that power is enough to generate over 350 million transactions on the Algorand blockchain. It'd be about 1.5 Bitcoin transactions, by the way. And then the other story is the fact that, you know, it's quick, right? So Swift payment, you know, messaging system to handle 350 million transactions, that would take about a month to do. And with Algorand, it would be about 90 hours because it's 24/7 round the clock. And again, from the sender to the receiver, a lot of good news there. So I got links on all these. We'll give you a link to the deck at the end if you want to research these a little bit more. So again, some more great ideas, you know, when you're thinking about doing work. Another big announcement we had, it was about El Salvador government. So now we're getting governments involved to utilize technology, blockchain technology. And El Salvador is looking at putting all their records, all the government records up on the blockchain through Algorand. It's a lot of good stuff there. Also, we have copyrights. You know, this is a natural. These are NFTs is what these are. These are non-fungible tokens. And for those that are brand new, what a non-fungible token is basically like a collectible. It's a one-of-a-kind item. You know, a good example is a copyright, right? It's a unique to an individual. They have that. And now, you know, one of the problems with copyrights is on a country by country basis. And now it's global. There's no boundaries. It's global and open infrastructure. You have end-to-end protection, and it really is the future of that industry. And the Italian Society of Authors and Publishers has put up over 4 million NFTs on the Algorand blockchain for over 100,000 creators. And so this is copyrights for the first time that are represented as digital assets. So that's another good idea for you as well. And even the NFTs were on a skit on Saturday Night Live not too long ago. And the list goes on and on. Really, just about every vertical market has a use case for blockchain. You know, tamper-proof charities. You know, you got to have an audit trail of where you know, funds came from and where they're going to for every kind of charity organization. So that improves the transparency of social services. Anything that requires an audit trail, you have that built right in with blockchain. That's what it does. It's an immutable ledger. It doesn't change. The only time it changes is when you add another block of transactions, and then that becomes immutable after that's done. And then also voting, tamper-proof. That's a big, you know, seller. And the fact that they can't be changed. You know, it's legitimate. Healthcare, again, providing global access medical records. Say I travel out to Europe and I get sick and I go to a doctor out there. Wouldn't it be nice if I can control my own medical records and access to that and provide, you know, the information to them. And so the local medical team has what they need to do their job right. And then finally, the automotive industry, really ripe for blockchain. You know, anything with supply chain, is really a great solution to look at for blockchain. You got, vehicle integrity, for example, on used cars. You can see details of wear and tear on the parts through sensors that are in the engine writing out to the blockchain. So really good food for thought. The ecosystem growing very huge to in the technical, financial segments and the whole ecosystem of applications, very huge in terms of partners and everybody that's really getting involved with Algorand. A lot of excitement, around this protocol. And so, what is the protocol that Algorand uses? Is called Pure Proof of Stake Protocol. And true scalability. We've recently been benched at over 1,300 transactions per second. That's going to go up even higher. My understanding is soon to be able to handle about 10,000 transactions per second. That's, Visa, MasterCard kind of throughput capabilities. And the block times are under 5 seconds. And I think that's going to be getting down to about 2.5 is what I heard. And then also infrastructure longevity. Everything is open sourced on the GitHub repo for the blockchain. Provides a lot of technical flexibility with all the SDKs and everything that we have. A big ticket is the transaction certainty. There is no forking in the Algorand blockchain. Once you do a transaction, it is committed and written out to the blockchain. Extensible platform, lots of great tools to extend the development capabilities, and we'll be covering a lot of those here today. We talked about how green this blockchain is. It's very energy efficient, and then also cost efficient. And this is a big one here. It's like a 20th of a penny. I've been working with a student from Lehigh, and he's been developing an application that is a one where it's like a fundraiser, right? A kickstart program. And when you have people contributing to this Kickstart program, if the entrepreneur doesn't reach the amount of money they want to raise for this, everybody that's trying to invest in it will get their money back, right? So with Ethereum, that would be like $20 for every person that's trying to go into this particular effort. And and that really makes it prohibitive to kind of like do this from a logistic standpoint, because it's just going to cost so much money if you get all these folks that are contributing, and then you got to pay $20 a head on top of that. Somebody's got to pay for that. Where's that going to come from? And with the Algorand, it's a 20th of a penny. So he's writing this program in Reach, and I told him to have two modes of returning the money. One, if it's Algorand, just do it, and if it's Ethereum, have them come to the application to request the monies back. So these are the types of things you start looking at when you start going to other platforms. It might be cool, might work good in testnet environment, but really what you want to look at is production. What is this thing going to need to run in production? And then true security as well, as we talked about. And lots of metrics are always available. You can always take a look at these on our dev portal. You can see here, we've got you can see the latest block times, how quick they are, average transaction fees, and number of transactions at any point in time. All righty, so we'll get into the heart and soul of your solution, layer one. And we got basically layer one features, right? Which are accounts, standard assets, atomic transactions, smart contracts, and reporting. So for the new folks, there's 3 types of accounts. Once again, you got standard account, you got a multi-sig account, and logic sig. So what are these? Standards like an individual account address. Multi-sig might be used, for example, in a board of directors. Maybe you got 10 accounts in there, and you have defined some kind of threshold. It could be 5, 6, maybe whatever you want for your organization. And if 5 people sign off on it, then it'll go ahead and sign off that transaction for the multi-sig account. Logic account is a smart contract. It returns true or false. If it returns true, it signs the transaction. If it doesn't, it won't go anywhere. So let's drill into each of these a little bit. ASAs are fungible tokens. These are stable coins. Also, you have another example would be cryptocurrencies themselves. These all each have the same value. You look at restricted fungible tokens. This is where it involves some kind of clawback capability as well. Non-fungible tokens are in-game items, supply chain, is another good one. Certifications. These are all unique. Collectibles is the one I really like to think about, like, you know, baseball card collections. You got lots of metadata around a baseball card. Is it new? How unique is it? Is it rare? Is it, you know, where to come from? All these kind of things. Is there a certification with it? These are all things that play into it being unique, just like real estate. You also have maybe one condo in one part of town, another in another, but they're the same in terms of maybe 2-bedroom, 2-bath, but the values are different because there's, you know, one's near a shopping center, the other one's near transportation, and, you know, the list goes on and on. So you get the idea. There's a lot of different metadata associated with each one of these NFTs, and this has really become big for also for artists and musicians as well. They are ripe for using standard assets and as part of their process. You know, there's no middleman involved once again with Algorand. So the musicians are looking to maybe reap more profits. Right now, they get a very small percentage, musicians do, of songs that they release, for example, and the record companies are taking a lot of it. So we're seeing a lot of transformation here in the way we've seen things done before and the way things are going to be done in the future. Let's take a look at our first demo. This is AlgoDesk. This is the tool that helps you create one of these fungible or non-fungible tokens. I'm going to go ahead and connect my wallet. I've got AlgoSigner here. I've got an account ready to go. This is on testnet. I'm going to go ahead and create this visually. So even if you're not a developer, you can use something like this to go ahead and do that. So let's give this a name. Let's call it Russ, and I do like pizza. I think the first transaction in blockchain history was for pizza. That was the old Bitcoin story. And then let's go with 100,000. Now, if you wanted to make this an NFT, you would give that a value of 1, or you can give it a value 10, let's say, and then make this decimal point 1, right? So that would be 1.0. It's still going to end up being 1 total for each one, but you can divvy it out into 1/10 each for 10 folks, right? So there's different, you know, that's a proportional kind of a approach. So let's go ahead and just create this. I'm not going to have any decimals. You can put a URL if you want in, and also we have ARC guidelines, Algorand requests for you know, information on how to actually make the best of this. You can maybe create a link to IPFS, for example. Let's say if you're putting up an NFT out to the site, or you can have a URL linked to your website or to an application. And then also you have all these different roles that are assigned with asset management. One is an overall management role. You have a reserve role, a freeze role, and a clawback role. And these could all be modified to different account levels. Finally, you get a note field. And this is a free structured field that you really can put anything you want to in your application. Some developers will use this even to house it like a JSON structure that would be usable for the application you might be running. So let's go ahead and create this. And now we're going to go ahead and sign this again through our one of our 3 wallets that it offered up originally. So let's see if this will go ahead and create this. Creating the asset right now, and then we're going to go ahead and sign this.
You could probably have it fail 5 times and it would still be faster than
there we go. There we go. Yeah, you're right. All right. Not sure what the glitch was there. Not sure if I fat fingered that, but we'll find out. No, it worked. Okay. Now we're going to wait for confirmation. So done deal. Now this is being written out to the blockchain. And then we have these explorers, right? So I'm going to view this transaction. One of them, this is the Algo Explorer. There's another one by PureStake as well. But here you can see the details of that transaction that we just did. And you can see the name of it, total supply, decimals, everything that we just did. The text, for example, down here in the note field, there's the test that we put in there. And there's a section for more information. So what's nice about this, you can instantly see the results, you know, of your work and testing when you're doing development. And then we get into atomic transfers, where we have all must succeed or all fail. So in this example, person A is trying to buy a ticket, could be a FIFA, you know, football ticket, right? For 50 algos to person B, and person B is going to send a concert ticket back to person A. Well, in the old days, you know, lack of trust, right? You don't know who you're dealing with sometimes. You know, you typically buy things from people that you trust or know, but you know, you're dealing with a global solution. You're not going to know folks a lot of times that you're actually integrating your transaction with. So person A is fearful of what? Of sending over 50 algos to person B, but never getting the concert ticket, and then they would lose it. Well, with atomic transfers, all of this must succeed or none of it will. So person A will only give up 50 algos if person B actually sends a concert ticket to person A. End of story. So what does this do? This guarantees exchange of goods. This is also the secret sauce for building solutions with and dApps. And this is a great thing to kind of understand. I got a demo on this as well, showing you how to do that from the SDK code in a little bit. And then we get atomic transfers. What is this used for? More at a high level, like circular trades, group payments. You can combine this with other technologies as well as do instant settlement for complex multi-party transactions and distributed payments. Finally, we get to Algorand smart contracts. This is where you have the TEAL, which is the transaction execution privilege, assembly language. And, why did we do, assembly language? Well, it's lean and mean, right? You have to have something that's very performant in a global blockchain like we have. And that fits the bill. It's extremely efficient. But what do developers like to do is they like to use a higher level language, right, to create these. And then there's more and more choices coming out now to be able to do something like this. You have the Python enabled compiler, which is PyTeal. So all those that checked off Python earlier, you're good to go there. Reach is like a JavaScript type approach. So again, I noticed we had some JavaScript experts out there. The Reach can also have a front end through remote procedure calls in any language. Could be Go, Python, C#, and the list goes on there. And then speaking of C#, there's a brand new extension for Visual Studio I'm going to show today as well, which just kicks butt. It is awesome. File new, and you got yourself a smart contract application. And it's pretty cool. And so you got smart signatures as well, these approved spending transactions, and then smart contracts provide the transactions with global and local storage, global at the blockchain level, local storage at the account level. And these are all combinable with other Algorand technologies. So to kind of sum this up, you got a UI layer back end, with all your Algorand SDKs, REST APIs, maybe smart signatures executing, and you get one of three different transaction types. You have a payment, so that goes from account to account here. You have assets, could be fungible, non-fungible tokens that you might be trading or creating or destroying or managing. And then you have application calls, right, itself with smart contracts that provide the ability to write information out to local state at the account level or global state at the blockchain. So I like this overall dApp architecture. Finally, we get into Indexer, which is a great tool for doing queries against the data that is in the blockchain. This is actually, not rocket science here. It just offloads the AlgoD process, capture that information into a real database. And in this case, we're going to PostgreSQL. And then you can also see that being used by being able to do queries against that. All right, so to tie the section together, combining layer one features into solutions, this is a voting solution. Now, this is all going to be autonomically grouped. So you got a voting commission that issues a spending voting token. And then there's a vote for candidate A. Then you have a voting smart contract to do the validation. Once it validates, then it'll increment candidate one total to global state, right? So everybody can see it. And then you see it combining layer one features and crowdfunding. You have, again, this is all going to be atomically grouped, and this is the crowdfunding kind of solution I was talking about before, where you have, a threshold you want to meet, and then if you don't meet it, then everything's got to go back, because it's atomically grouped. And you see there, you've got use one claims, the escrow funds right there for doing smart contract with crowdfunding. All right, now getting started, lots of great tools. First and foremost, you want to go out to the developer portal. It's developer.algorand.org. If you're brand new, go under the brand new section, brand new to blockchain, it'll get your feet wet there. If you're looking at more specifics on Algorand, again, there's sections in there to go ahead and do that. And then also Discord. This is a must. Just go out to this URL here. I think it's invite/Algorand. I think we got a short mnemonic now for that. And then go out to our Discord server and join that. There's over 10,000 developers on the Algorand Discord server, over 30,000 folks total. It just keeps growing. It's even bigger than that now. Developer resources, once again, you know, you can see here, you've got blockchain basics, smart contracts, tokenization, integration right off the menu. If you scroll down the page, you'll see that there's more information on smart contracts, and then also a lot of information under the IDE section and the tools section of the ecosystem projects. And then also VS Code has a lot of extensions as well. So when you're in VS Code, make sure you type in Algorand and you get the VS Code extension. There's also a Reach one too. If you're going to be using Reach, I'll be talking about that in a little bit. What you want to do initially to get going is a sandbox. Ryan's going to cover this in depth tomorrow. But basically you clone it and then it defaults to a private network that you can use by just doing a sandbox up. Otherwise, you can access any of the networks as well as BetaNet, TestNet, and MainNet. They're all supported and DevNet too. All right, which is a nightly build. And then DevNet is pretty cool because it doesn't increment the blocks. It only increments the blocks when you do a transaction. So here what we have is the lay of the land in terms of tools, right? Everything in the red box here is what Algorand provides. We got the 4 SDKs that are supported through Algorand: JavaScript, Java Go, Python. These are also, you have PyTeal and Teal. A lot of other SDKs that are up on the ecosystem page with Rust, PHP, Dart, C#, Swift. A lot of great tools on the right here in the ecosystem. Reach is one of them. You got Algo.io. I showed you that one already. AlgoD is a great tool as well. So lots of good information there. So I'm going to go ahead and show you a demo here on the first transaction. I'm going to go out to the first transaction in the doc. So you can see the docs here. This is the first transaction in Python. And you could actually click this try live demo. You don't even have to install anything. You just hit run and it'll go ahead and install everything automatically in a sandbox. And then you can see it execute all the code. The next step here is to install the sandbox like we talked about. Again, I got videos and more information on each one of these, and then you want to install the SDK. Once you do that, you're good to go. You can start creating, solutions with the SDKs, and everyone's got this kind of the same sequence of steps that you would do. If it's testnet, you want to fund the account with the faucet. And then also, I'm going to show you that live in this next demo, and then connect your client, and all the code is here. So what I'm going to do is actually run this live. Let me bring up the GitHub repo. I have a hackathon GitHub repo on Algorand-DevRel. I have the link for all the code at the end as well. And let's go ahead and this is the getting started Python one we were just looking at. I'm just going to hit the run button here, and I've got my breakpoints set already. And once this hits the first breakpoint, I want to point your attention to the algo address and token. Now, if you brought up Sandbox, you would see that you have the localhost 40 and this long string of A's, and it's right in the README file. So if you're using Sandbox, that's the address and token you would use. I'm using one here that we have for demos, which is this Academy one. And then if I come down over here, you can see we've got the creation of the client. Right, so here's your AlgoD client with this SDK call to create that instance, passing in that token and that address. And now, once I've got that done, then I can start executing things like, okay, give me the account info based, off of that client. So there's a lot of functions there that are available. Now we'll go ahead and print that off down below. And we've got 0 microeggles. Oh, why is that? Well, we created a brand new account up here on top with this generate account function. So here I'm going to go out to the dispenser, and this is what I was talking about for testnet. And then you can see it automatically populated the Algorand account there with that link that we had using the account equals parameter. And then what we see here is the funding now for 5 algos in that balance. So if we go back now to the code and just type in, yes, we got the do re mi. Now it's going to go and get that information again on the client. You can see the new balance is going to be 5 million microeggles. So that's the same as 5 algos. And now we're going to build the transaction. So this is important. There's you have the get the parms that you need for the network. So this parms has information like the fee, the first round, the last round, what network you're running on. But once you have that, the 3 steps that you need to do for every time, for every transaction is, number 1, you want to do the payment. So that's going to take your from address, to address, parms, amount that you want to go to. And then after you've done that, Then you want to sign it. So this is using your secret key on the account. Every account has got a public key and a secret key. You never ever share the secret key. You always, the public key is okay to share on occasion, especially if you want money to come to you. That's, you kind of have to do that. Say, okay, send it to this address. There you go. And then you have sending the transaction then is the last step. So after you do the payment, you sign it, and then you're going to broadcast it to the network. Now, if there's anything wrong, like insufficient funds or anything like that, that's the step that will fail. And you'll see that come out in their error log. Now we're waiting for the confirmation of built-in function to all the SDKs, and it went ahead and completed, and you can see all the information print off down below that the transaction was successful. So that's that one. Now, the next one I want to show you here is the atomic transfer. So let's go ahead and show you that one. So in the same folder, I'm going to go do this one in JavaScript. And so I'm going to go ahead and run this, and we're going to see that we're going to do two transactions here. One from account A to account C, and another one from account B to account A. The first one's for 0.1 algos, the other one's for 0.2 algos. And I'm going to go ahead and just fire this up, and we can see what this looks like in the code. So I'm going to go ahead and get down to the accounts, right? We're going to define who these accounts are. And then we're going to go ahead and make this payment like we talked about with that parameters for transaction 1 and transaction 2. So this is the make transaction method. Now, the important part is to group these into one transaction. So we're going to take both of those transactions that are in an array here, and we're going to get a text group ID. And so then that is going to be used to do the signing. And then you can see here, now we're going to go ahead and send that transaction again out to the broadcast to the network, wait for confirmation. And then you can see these balances indeed changed, and it was successful down below by these statements. So that gives you a quick lay of the land in terms of a couple key concepts to learn. And then let's get into smart contract development in DApp. So you can see PyTeal is one of the choices that you have. So it's really Python code, and you compile it, and it's going to generate teal code. And then once you have the teal code, the SDKs can compile that to bytecode, which you would use as parameters for any of the calls that you're using with contracts. And then, so let's take a look at this. So what I have here is a demo that is going to be for looking at teal. So this is going to be like a periodic payment scenario. So we're going to have some template variables. These goes like you have integers and some byte arrays as well here for things like the duration, the period, the amount, receiving account. Then let me just go ahead and run this. And up at the top, I want to point out this is the import that you would need, the PyTeal import, because what we're going to be doing is taking this Python, and then we're going to be generating teal from it. And then you can see here, I've got the first breakpoint I hit with the template variables. Then I'm going to go ahead and take a look at doing a transfer and then closing it out. So the transfer is going to have the receiver, the amount, and then the first valid parameters, for example, and then the receiver here. And then this final one here is going to be the actually paying the escrow. And then we can see right here, we're going to print out the teal right down below using this compile teal method that we have right here. Jason is going to be doing the third session. He's going to go into in depth the technology that I just showed, but that's really the basic idea that you have with PyTeal. Okay, so let's talk about AVM and what that is. It's an Algorand virtual machine. And the consensus network observes when a smart contract app calls a transaction. It sends it to the execution environment. And then the execution environment is commonly known as a virtual machine. So it's a runtime within the consensus protocol. And what does that mean? Well, it means that smart contract program logic is executed and evaluated, and either include the transaction in that box or discard it altogether if the evaluation fails. And we got more details on that on our site as well. There are a couple of key calls you would need to get for use inside of SDK type applications. One is the getting the address for the application. You're going to get an application ID back. And then if you want to get a full actual address to that, you can use the address for application in Java, JavaScript, and then you also have the actual code for Python and Go as well. All right, so we took a look at that. Now, as a follow-up, your homework assignment is to click on this link here, this YouTube link. That's a playlist of how to actually code in Teal and PyTeal. And you see there's a PyTeal course. So it goes through everything, setting up environment, writing a simple contract, and then it's really well done. I highly recommend this for those that are going to be using PyTeal. All right, let's talk about Reach next. So what is Reach? So it's a program, it's a compiler, and it is a deployment tool. It deploys to multiple blockchains with the same set of code. So that student I was talking about, he was deploying to Algorand as well as Ethereum when he was testing the application. And this is how it works. You basically have a back end, and then you also have a front end, right? And the back end is the one that is a JavaScript-like Reach code. This is the one that will generate, deploy, and interact with the smart contract logic on the front end automatically. So to do that, it's got to define the front end interfaces. You define who the participants are, and you have some logic in terms of what the implementation is there. You also have a very important feature on verify and commitment, and you can see that in the demo I'm going to show in a minute. And then also on the front end, then this is the piece that could be done in Python, Go, JavaScript, C#, to name a few. And this actually has the logic in it for things like, blockchain specific code or maybe creating, I don't know, a random number or something like that might be used in the back end. So this is your user interface basically. So you compile that and then run it, and then it'll deploy it out to the Algorand blockchain. I wrote this build with Reach docs in the doc site of the developer portal. So this goes over doing an auction. Again, that's another good homework assignment, is to go through and follow this here if you're looking at Reach as a way to build dApps. And then also I published this game solution using Mora. This is actually a age-old game. Those who are not familiar with it, you got to shoot fingers. Each opponent shoots fingers, and they got to guess simultaneously the total between the two. It's great for teams, great for parties and picnics. My family used to play it all the time back in the day. Back behind the barn or back over in the field someplace, and you'd have teams, playing this. And of course, usually there was beer involved somewhere along the way, in that game. So anyway, let's take a look at this. I'm going to show you this Reach More application here, and let's just go ahead and run this first. And I can show, and this is a simulation of that game I just talked about. And I've got two pieces of code I'm going to show you here. One is this backend. All right, so this is the Reach file, this RSH file. So while this is executing, you can see I've got the logic here to determine winner. You're going to pass in all of the parameters, the fingers from both and the guesses from both. That's got to come out with a winner. And many times it is a draw, as you can imagine. So the first one here, I'm not quite sure what's going on here. So Bob, there's a wager involved too in this. Again, tried to make this as realistic as I could based off of my memory of family outing events. So Alice shoots one finger, guesses total of 6. Bob shoots 2, guesses a total of 4, and the actual cone 3. So they got to do it again until there's a winner. Now, in this section here, I've got a bunch of asserts here. Asserts are very, very important in terms for doing verification. For example, for all the combinations, there always has to be a winner. That is one of the things you can test for. Also, if both throw the same guess, it's going to be a draw, no matter what, whether it's, it's accurate or not. You can't both guess the same thing. So things like that you want to think about. And that leads into the verification process. It looks like we got a winner down here. 6 was guessed and 6 was the actual thrown. And then you can see Alice's total went up and Bob's went down by a couple of algos that they've done. To further explain the code here, you've got who's the participants. So we got Bob and Alice. You also got the ability then to do wagers, right? To go ahead and accept the wager, put out the wager, and then you want to do a while loop, right? So this takes care of while the outcome's a draw, keep going until there's a winner. So one of the things that when I first wrote this, I was having Alice throw her finger, or the logic to throw her fingers and guess first. The problem with that is it could be deciphered by Bob, and he can have an unfair advantage. So what this make commitment does is it'll go ahead and salt that value out, and then unsalt it when you need to after Bob does his guess. And so then that's just some things you'll want to look at if you're doing reach development there as well. And then you come down over here and you got to publish the fingers, and then you actually have the commit out to the database. Then you can see the winning numbers are published and the outcome. And then finally, you have the payment, right, for the transfer. So I'm going to actually put 1 in here, and this is going to leave money on the table, right? You've collected enough wagers for 2 from Alice and 2 for Bob, and now we're going to pay half of that out, right? We're not going to do both of those. We're going to only pay 1 out. Let's see what happens when we run this. So this is one of the beautiful things about Reach is the verification process. And, this is something you would have to do manually with any other approach. And now you can see it comes up with an error, and the error is saying, hey, this could actually be 0. And, this fact that it would be 0 would be false. And your verification is very, very important when you're doing this. Now let's take a look at the front end as well. And on the front end, this is where you're going to use the Reach standard library. Instantiate that right here at the top. And this build file, this is the one that gets generated. It would have the teal code in it and the Ethereum code in it, and as well as other things. We're going to start out a new test balance here using some of the functions on that standard library. This is only for the DevNet environment. And then you also have the ability to get balances here. So we're going to use the balance of on each one of those accounts that you saw displayed. This is a little bit of the random functions I talked about for getting the players' fingers and the guesses, and that's winning. So really not a whole lot of code here, in this application. And so this is a really cool thing to start looking at in terms of, choices here. And then finally, we get this great new extension here from for C# developers and .NET. And basically, you just got to do a file, new project, search on Algorand, and there's an Algorand console app. And let's go ahead and take a look at this demo. Let me bring that up. I'm running this in my Windows VM right here. And let's take a look at the lay of the land here. The first thing I want to show you is this. If I bring up Visual Studio and I do a file, new, and come out over here, new project, I just type in Algorand. And now it comes up, and that's what I would select to do, and then hit next and go to town. Now I've already done that. What you'll need to do very simply when you get this is just modify the URI and token like we had talked about before. And really that's it. This other thing is good to go here. And then if you are restoring your accounts for test purposes, never do this in the code, by the way. What you're putting in your mnemonics, this is only for testing purposes. Again, that's in essence, your private key is what that is. So what I'm going to do here is show you how to do a smart contract in C#. So I got 3 examples that come with this template. This is a smart contract. If you take a look at where this is a definition, you can see this is actually part of the SDK, right? It's going to go into the actual binary of the SDK, and then you can see here this is just a little bit of a condition logic. So if it's greater than or equal to 4, you're going to log out 10, otherwise you're going to log out 20. Then you see you've got this transaction reference. And this uses this is about an ABI selector method that you're going to have, which stands for Application Binary Interface. This is a recent enhancement to the AVM to be able to have little snippets of code that could be reused over and over again. So more of like an object-oriented programming approach. And so you've got a couple that are written down here as well as part of that scenario. This invoke smart contract method. This is another great wrapper, right? That's as part of this project that you can utilize. And then also we have another one here, this unary operator, very, very simple to do a little addition. So that's part of it. Now, if you take a look at that contract wrapper, there's a lot of functions that are in here. You have the ability to deploy. You've got the ability to fund an app. These are all, wrappers that are available in this utility to go ahead and do all the functions in the life cycle of a smart contract. You can opt in, delete the app, clear the app. These are all the basic functions. And then you have another wrapper there for node configurations. Finally, if you take a look at the analyzers under the Algo Studio in this, you can see all the error messages that are possible, but here is the actual teal. And if you look at this, you can see that this generates a teal. So as you're typing in the code, it's regenerating the teal on the fly in this environment. And then what I would do is just go ahead and run this application, and then you could see it's going to end up, giving me a success when I go to run the application, and you can see the logic down here with the test contract. Again, you get all of this just by doing a file new, and the way you do that is through the extensions. You got to first add that Algorand extension from the marketplace in here, and you can see the ones that I have installed as Algo Studio. So you'd have this, and once you've done that, then it's available for every instance of Visual Studio that you create. All right, let's get back and wrap this up in the last section here with the ecosystem. And we got the ability for y'all to contribute to the community here with, writing tutorials, solutions, articles. So if you get a cool solution you come up with, write a solution, or if you found something that that you needed to do, and step by step to get up to speed on a certain task, take notes, right? And at some point you can write that into a tutorial, and we also have bounties associated with those. I'll talk about those in a second. Then you got ecosystem tools and project. Go to the tools part of the site. You can also submit a project there as well. I want to briefly mention Pipeline UI. This is a great vanilla JS SDK, as well as a React component library for your front end. So what you're seeing here are controls, just snippets of code that you can utilize to do things like deploy and opt in to assets, to call transactions, read global state. These are all done. You can see one here. This pops up a QR code and an address you can copy. You would have to normally create this by hand, and this is a UI control set on the front end that's very, very cool. And then you can see React specific components are available too. They even wrote, the guys over at Pipeline even wrote a front end for that Reach More simulation game in React, and there's the link to that down there for headline design. And then also you have all of these great Algorand specific controls in there. Get the Algorand address, you hit that button, and up comes the QR code. So lots of great SDKs as well. And this is the bounties I wanted to talk about with the Algorand Foundation. The foundation is the company that's responsible for token economics and ecosystem growth. And this is a recent snapshot. I just took this yesterday. You can see we've got bounties out there for tutorials that you can write. Now, Ryan and I work for Algorand Inc. That's the technology company, and that is the one that has all the engineers, all the consensus, code is managed and developed by Algorand Inc. And also we've got the DevRel team as well to boot on that. So, things to consider going forward. There's opportunities there for writing solutions and tutorials out at our portal. Plus, I think we have a monthly prize for a period of time now. It's like April, May and June. May has 6-week window there. All right, and then Twitter Spaces. Follow Algo Devs. We actually broadcast a stream there yesterday. We did a little testing and doing simulcast to YouTube and Twitter and LinkedIn and Facebook, and it was very cool, very cool. So great things to come with that in developer office hours right here. We'll be doing that coming up. Ryan manages that program. I help out with the presentations, the presenters, and we've gotten a lot of good feedback from it. So sign up at algorand.com/developers for the next event. And then in summary, I want to show you a couple things here. Number one, the PowerPoint link is there. Ryan, if you can post both of those in the channel, that'd be great. And then we covered a lot of things here today with, starting out with a blockchain intro for those that were new, and really some of the newer use cases that have evolved. And I'm very excited about things to come, especially, when you get players like FIFA involved. That it is just amazing what's happening to the whole ecosystem with Algorand. We took a look also at layer one, and we're going to go into depth on that tomorrow with Ryan on ASAs, atomic transfers, also smart contracts, and using Indexer as well to report on those. And we talked about the lay of the land in terms of what type of accounts there are. A lot of good getting started tools. Really, your main focus again is developer.algorand.org, as well as going out to the Discord server and signing up there. The ecosystem is growing leaps and bounds every day. There seems to be announcements that are just mind blowing. Any one of them in and of themselves. The code that I showed you, I have links for that. They're in the hackathon repo under Algorand DevRel. That more game I also posted over there. Just take a look at the folders. I put a brief README in each folder to specify what's going on. I have like a more 0. That's when you do an init, and then the next step is to, create the game logic, and then the next step is what I had showed you. Then I have a step in there for, all of the a folder more 4. I think 3. I think is the one for RPC coding, and I got a couple work in progress folders for using it with testnet, and then also using a wallet. Those that haven't been flushed out yet, but I pushed up there what I had done so far. So this is where I'm going to stop, and I'm going to ask Ryan if there's any questions that we got outstanding here from the group today.
Russ, you did an outstanding job. Thank you very much. Lots of questions that came through. We tried to answer them in line. Certainly, if we didn't get them answered, we'll be here tomorrow, same time. I'm going to step up and teach you guys getting starting how to set up your developer environment. We'll get that sandbox stood up for you, and then we'll start doing some code. We'll focus on Python and JavaScript, those two SDKs, and we'll get you some more in-depth code that will go through. I've got a repository that's got all these examples as well that we'll share, and then we're gonna wrap it up in another couple of weeks when Jason will come up and have a focus on smart contracts. So we're going to build upon this, and we thank you again for participating in the Encode Club.
Thanks so much for this great session, and for our participants, see you here tomorrow at the same time. The Zoom link will be different. If you're on our Discord, you'll find a Zoom link there. And if not, Eva will post an Eventbrite link in chat, and you can sign up for tomorrow's event. Thank you again, Ryan, Russ, such a great session. Looking forward to tomorrow and to our hackathon sessions also. So thanks so much, and see you tomorrow.